Okay, so how does your computer do a million things at once without breaking a sweat? Let's get into it.
You expect your apps to be super fast and responsive, right? Well, this is the magic that makes it happen.
The two big ideas are multithreading and multiprocessing. But first, what's a process and what's a thread?
A process is basically a running program. Think of it as its own little workshop, with private tools and space.
And threads? They're the workers inside that workshop. And the key thing is, they share everything.
So the big takeaway? Processes are loners, totally isolated. Threads are like roommates who share all their stuff.
And that sharing? That's where the problems start. What happens when two workers grab the same tool?
You get what's called a race condition. It's total chaos where the final result is just plain wrong.
Check this out. Both threads read 0, then both add 1. The answer should be 2, but it's 1. Yikes.
Okay, so how do we prevent this disaster from happening? We need some rules.
For threads, we use something called synchronization. You can think of it like a traffic cop for data.
One tool is a mutex. It's basically a lock. Only one thread can have the key at a time. Simple.
Then you've got a semaphore. It's like a bouncer at a club, letting a specific number of threads in at once.
So that's threads, but what about processes? Since they don't share memory, they have to, well, talk to each other.
And one popular way they do that is with something called a pipe. It's pretty much what it sounds like.
It's a one-way street for data. One process sends info in, the other reads it out. Safe and orderly.
So, threading or multiprocessing? Which one do you actually pick? Well, it all depends on the job.
And the big question is this: is your task I/O bound or is it CPU bound? Let's break that down.
An I/O bound task is mostly just waiting around for a file, for the network. The CPU is just chilling.
But a CPU-bound task is all about raw number crunching, like video rendering. It's pushing your processor to the max.
So here's the cheat sheet. For tasks that do a lot of waiting, use threads. For heavy lifting, use processes.
And really, the golden rule is this: the less stuff your code has to share, the fewer headaches you're going to have.
So what's next? With billions of devices all talking at once, how do we manage all that? That's the next big challenge.